Hi. Now in this video what I want to do is show you how we go about finding the equation of a tangent to a curve, and also how we go about finding the equation of a normal to a curve. And to demonstrate this, I've got this curve here, y equals some function of x. And if we take a point on the curve, let's say we take this point here, and this point has coordinates, say, x1, y1. Now a tangent to the curve at this point here is a line that just touches the curve at that point, something like this. So this is our tangent, and we're going to be wanting to find the equation of the tangent. And I also mentioned normals. What is a normal? Well, a normal at this point is a line that is perpendicular to the tangent at that point. So we're looking, say, at something like this. And obviously these lines, they carry on, okay, outwards. But so I've just shown part of these lines. So this line then is a normal. We'll just write that in there. Now, when it comes to working out the equations of these lines, we should be familiar with the fact that any line has the form y minus y1 equals the gradient m multiplied by x minus x1, where x1, y1 represent a point on the line, and it will be this point here. And as I say, m is the gradient. Now, to get the gradient for the tangent, what we need to do is just differentiate the curve. In other words, we'll just put here that m is equal to dy by dx. Or, if you're working with function notation, it is f dash of x. Now, if we want the gradient, though, at this particular point, we've got to let x equal x1, and it will give us that particular gradient then. Now when it comes on to the equation of the normal, then the normal is going to have the form again, y minus y1 equals the gradient. I'll just leave that blank for a moment though, multiplied by x minus x1. Now what is the gradient? Well, since these two lines are perpendicular to one another, there's a relationship between the gradients. We should be familiar with the fact that if you've got a gradient, say m, the perpendicular gradient is minus 1 over m. Okay, the negative reciprocal of this, so that the product of these two gradients, that's if you multiply them together, in other words, comes to negative 1. Now what I want to do is run through a numerical example, and I've got a question here where we've got to find the equation of the tangent and normal to the curve y equals x squared plus 1 at the point where x equals 3. So when I'm doing a question like this, it's always a good idea to draw a sketch of your curve. And it just so happens that the curve y equals x squared plus 1 would be a parabola passing through 1 on the y-axis, and it's going to look something like this, okay? So what I need to do first of all is we'll differentiate the curve to get the gradient at any point. So we'll just start off with the fact that we're given y equals x squared plus 1. And if we differentiate this with respect to x, in other words, find dy by dx, then differentiating x squared gives us 2x, and the constant goes to 0. So this gives us the gradient of the tangent to the curve at any point x. Well, I want to work out what this point is. We know that the x-coordinate, x1, is going to be 3. So I need to get the y-coordinate, the corresponding y-coordinate. So what I'll say is when x equals 3, we know that the y-coordinate will be 3 squared plus 1. if we substitute it into there, and that comes to 10. So we've got this point x1, y1 now. Its coordinates are 3, 10. What we need is m, the gradient of the tangent, in order to get the equation of the tangent. So what we can do is we'll work out what the value of dy by dx is when x is 3. So we'll just put here and dy by dx equals, well, it's 2 times x, so it's going to be 2 times 3, which is clearly 6. A positive gradient, which is what we would expect here. So therefore we've got the gradient of the tangent. Let's just put it down here as a reminder. Gradient of tangent, okay, will be equal to 6. And it means that therefore the gradient of the normal here, if we apply the perpendicular gradient rule, that is the product of the gradient should come to -1. All we had to do was just do the negative reciprocal of this. So in other words, -1/6. Notice how they multiply together to give you -1. So I've got everything I need now to get the equation of the tangent and the equation of the normal. So we'll start off with the equation of the tangent. I'll put an intro here rather than just writing it down. Just gives the reader some idea, hopefully, of what we're doing. So we'll just say the equation of the tangent, and I'll also put at the particular point, which is 310, and we'll just say what it is. And using this format here, it's going to be y minus y1, which is 10, okay, equals m, the gradient. The gradient of the tangent is 6, multiplied by x minus x1, which is 3. And you could leave it like that. Quite often you get a question which just says, find an equation for the tangent, and that would be sufficient. You might want to put it in the form y equals mx plus c. If you do, then we just carry on and we can expand the bracket and add 10 to both sides. So we get 6x, would have minus 18, and then if I add the 10 to both sides, it's going to come out at minus 8. So that would be the equation of the tangent if I want to put in the form y equals mx plus c. And it's always good to look at it like this because, again, you can just check to see whether it looks sensible. For my sketch here, this isn't quite sensible because, okay, we've got a positive gradient here, but the y-intercept would be at minus 8. So it would be a lot steeper coming down and intercepting the y-axis here at -8. Well, let's go on and work out the equation of the normal. So we'll just put a subtitle here again, equation of the normal. And again, I'll just say that at what coordinates we're doing that at, and that's at 310. And what is it going to be? Well, again, using this form here, it's going to be y minus y1, so it's still 10, equals the gradient, which is now minus 1/6, multiplied by x minus x1, which is the 3. Now again, I could leave it like this if it said write down an equation of the normal. But maybe I want to write it in the form ax plus by plus c equals 0, where a, b and c are integers. If I'm asked to do that, it's always a good idea to just multiply by your fraction here, 6 in this example. So what we'll get is 6y, and then minus 60 equals, and if we multiply this by 6, we're just going to be left with minus 1 times the bracket. So that's going to give me minus x plus 3. Now if I add x to both sides and subtract 3 from both sides, I'm going to end up with x, then plus the 6y, and then we've got minus 60 minus another 3, which is going to be minus 63, and that equals 0. and that's in the form ax plus by plus c equals 0, which sometimes you're asked to do. So I hope that's given you some idea then on how we can go about working out equations of tangents then and normals to curves.